Hi, my name is Krista Wells, and I'm going to be talking to you about quartiles and box plots. Now, we have learned that the median is identified as the middle value in a data set. It essentially divides the data set into two parts. Now, a data set can also be divided into four parts. The scores contained in these four parts are called quartiles. As a result, a data set has three quartiles, as you could see from here. The lower, which is Q1, the middle, which is the median and is called Q2, and the upper quartile, which is called Q3. Now, the lower quartile, which is Q1, is the middle score of the lower group, and we're going to go over that in a minute. The middle median, Q2, is the middle score, which is right here. That middle score divides the data set into two equal groups. The upper quartile, Q3, is the middle score of the upper group. So you have Q3, Q2, and then Q1. 1, 2, 3. Now, in terms of quartiles, we must also note the interquartile range, which is abbreviated IQR. To calculate the IQR, we would subtract the lower quartile, which is Q1, from the upper quartile, Q3. So we would do Q3 minus Q1 equals IQR. The IQR range is a measure of the spread of the middle 50% of the data set. And we're going to go over an example. There are 20 students in the ELA class. This will constitute a great number of test scores. We're going to find Q1, Q2, Q3, and the interquartile range for the test scores. Now, as you could see here, this is the test scores from our Period 1 class. The first thing we would do is reorder the values in the data set from lowest to highest. Now you're going to see here that the median is 71. Okay, again, you see we have 20 scores, that's even, so we did not have an exact median number. We had to add 71 plus 71 and divide it by 2, and we get 71. So that is our median. Median equals 71. And that is quartile 2. This is our quartile 1. So we don't have a middle number. The middle number is between 56 and 64. So for Q1, we have to add 56 plus 64 equals 120. 120 divided by 2 equals 60. So our Q1 is 60. The middle score in the Q3 region, again, we do not have a median number, so we have to add 86 and 87. 86 plus 87 equals 173. 173 divided by 2 equals 86.5, and that is our upper quartile Q3. We're going to subtract Q1 from Q3. So Q3 was 86.5, and then Q1 1 was 60. And we get 26.5. That is our IQR. Now there are a variety of methods to present data in statistics, such as bar graphs and histograms. But another great method is by using a box plot, also known as the box and whiskers plot. The box plot was formulated by John Tukey in 1977 and really presents and compares data sets that do not follow a normal distribution. And we're going to look at an example in a minute. Now, as you can see here, this is a box plot. Now, a box plot will contain two whiskers that project out from the box. That's right here. These are the two whiskers. The highest value in the data set is represented by the top whisker. Top whisker. The lowest value in the data set is represented by the bottom whisker. Now, a box plot also contains the quartiles as we just went over. Do you remember this was Q1, Q2, and then Q3. And again, remember, Q2 is equal to the median of the data set. From viewing a box plot, we learn about a data set's highest and lowest score, its range of scores, median, and upper lower quartiles, and its interquartile range. Okay, so for example, in this figure we have a box plot. Now, this box plot can reveal the highest and lowest values in the data set just by looking at top and bottom whiskers. This is our bottom whisker, and this is our top. The top whisker is set at 58, and the bottom whisker is set at about 15. So the highest value in our data set is 58, and the lowest value was 15. So the range of scores is 58 minus 15, and that's 43. The median, which is Q2, is set at 41. So that's Q2. The upper quartile is, do you guys remember? Q3. And that is set at 50. And Q1, which is the lower quartile, is right here. And it's set at about 23. 23, quartile 1. So since we have Q3 and Q1, now we could calculate the interquartile range. So again, it's Q3 minus Q1 equals 50 minus 23, 27. So from visualizing the box plot, we can deduce that the bottom 25% of the values lie between 15 and 23. The top 25% of the values lies between 50 and 58. The middle 50% of the values lies between 23 and 50, which is right here. The median Q2 line is situated closer to the upper quartile Q3, indicating that the top half of the values is grouped closer to Q2 than Q1.